This is the neutralization and hydrolysis lab. Normally we would do some of these chemical reactions, but for this purpose, we're just going to use it as a worksheet. It's basically practice problems for the neutralization and hydrolysis notes. So basically what you're doing is pretty simple. You're gonna, on this side of the sheet, you're gonna take an acid and a base and you're gonna put them together. And the thing about acids and bases, when they come together, they are gonna make salt and water. The way to think about it is the H from the acid and the OH from the base are always going to make water. And then what's left over has to be, you're going to have to do a couple things. One, you're going to have to assign the oxidation numbers, use the crisscross method to predict the products. So the way I would do that is simple. Na is in group 1, it's +1. If I didn't know that, if it wasn't in group 1, I would have to use the fact that OH minus is -1, and when I set this whole thing equal to 0, it would make Na +1, and you can figure it out that way too. H is in group 1. It's also, well, H has its own rule, it's +1, just like group 1. F has its own rule, it's -1. Again, you could solve it either way. So F is -1 here. And then when I crisscross 1 and 1, it's just NaF. So this is the salt, this is obviously the water, and then you would go in and balance these, and balancing them shouldn't be too hard. In this case, they'd all be 1s. Okay, and that's all you're gonna do for this entire sheet. I'm gonna do one more with you. I'll do one of the harder ones. Let's go down to number 9. These aren't incredibly hard. They're really no different. They look different, that's really it. So for number 9, this is on your acid table. That should be table K, and it's actually HC2H3O2. It's acetic acid. And if you look on table K, it shows you which one of these H's comes off. Not all of the H's leave as an acid. This is the H that comes off. And then this part is the polyatomic ion that is going to stay together and never break up. And then for BeOH2, this one's an easy one. The Be is obviously going to be the ion, well, the part of the salt, and then the OH is going to be what makes the water. So these two are going to make H2O, which is water. And then this next one, I should probably do that up here too, is going to make my salt. So the way it works is simple. OH is -1 as a polyatomic. Set this whole thing equal to 0. That makes Be +2. You could obviously do the multiplication and the math down there. That's totally fine. So Be goes first because it's positive. So there's Be +2. Now, this thing, you're not going to solve the individuals. You actually just look it up on table E, or you can find that on table K. They tell you there as well. It's -1. Okay, so now is -1. When I crisscross a 2 and a 1, I'm going to get a 1 here. I don't write it. And then this thing would be 2. Okay, so it would be that whole thing doubled. So that's where the parentheses and the 2 came from. This would be our salt. And then this would be my acid, base. And then balancing these are not very complicated. You would have to put a 2 here because you need 2 of those, and then a 2 there, and then those would be 1s, and it's balanced. And so it's going to look like that. Again, these ones with stars, they're not super hard. They're just using things that have oxidation states that aren't as easy. Like this one is a 3, and then it's a 3 and a 2, and then I think a 2 and a 3, basically. So it's nothing complicated. It's just, it's not using 2s and 1s or 3s and 1s and things like that. Okay, so that is neutralization. Now the back page is going to be hydrolysis. So it's the same idea. The H2O is going to get split up into H plus and OH minus. This is important to remember because what we're going to have to do is we're going to have to figure out what part of the salt, and again, these are going to be your salts. So you could literally, if I knew how to spell salt, there we go. You can just write that in the whole way down. Obviously, this is water the whole way down. That's not a big deal. And so what you're going to do is you're going to assign your oxidation numbers. K is group 1, so it's +1, Cl is -1. Once I know these oxidation states, I now can say, okay, K +1 is going to go with OH because it's minus, and then H plus is going to go with Cl because it's minus, or plus or minus 1. The ones are optional. Crisscross them, they're done because they're all ones, and then this is going to be your base because it got the OH. Is going to be your acid. It doesn't matter if you do the acid one first or second. The way I say it is salt plus water makes acid and base. I'll always say it that way. I don't know why. It's just the way I learned it. But I mean, to say salt plus water makes base and acid, it's the exact same thing. So it's totally fine. I just happen to do it this way. I'll do one more just to show you. So AlBr3. Al is +3. Br is -1. General rule with anything in the halogen family that is from chlorine straight down, if they're in compounds like these, they're almost always going to be -1, but it's not a guarantee, so that's why it's not a rule, but it's like 90% of the time it happens. So now I'm going to put my Al here just to show you the opposite way. So it's plus, therefore it's going to go with OH because it's minus, and then Br is minus, so it's going to go with H because it's plus. Crisscross 1 and 1, they're fine. This makes the acid. And then crisscross here, I'm going to need to put parentheses around that and a 3 outside, so that 3 goes there, and the 1 is unwritten, and this is my base. And then you could go in and balance this. Obviously, it's not going to be all ones. For balancing, it's going to be a 3 there, and then a 3 there. And so that's balanced. So it doesn't matter how you do it, whether you did salt plus water makes the base and the acid, or salt plus water makes the acid and the base. Just remember, if they are flipped, the 3 and the 1, the balancing coefficients are going to go with them. Meaning if the HBr was here, there'd still be a 3 in front of the HBr. It would just be on this side. And if this AlOH3 was to the left, the 1 would follow it. And then it would be base and acid instead of acid and base. So it doesn't matter how you do it. There are some questions at the bottom. I do want you to write these out. Assuming we do come back to school, this is going to be turned in and it is going to be graded on, we're going to make it on 4th quarter because we're definitely not coming back before 3rd.